has much to tell us about the nature of the universe, but the microscope has had much the most direct effect on our everyday lives. Carol's been to see one of the country's foremost independent microscopists, Brian J. Ford, a man who really knows his onions.
Oh. Well, I don't know what these have got to do with microscopes. I think they've got me cooking a little Hungarian goulash today for lunch.
Don't worry about it, Carol. This is all part and parcel of preparing stuff to look at under the microscope. That's not food, that's specimens.
Are you sure?
Absolutely. Well, why did you think I asked you to cut up the onions? They always make me cry. What we want is a tiny bit of that.
Okay.
And a tiny bit of that. Now, cut that one in half. It's
Okay.
that's too large.
Right.
If you'd like to bring those with you, we'll go through to the study and I'll show you something you've never seen before.
Promises, promises.
Carol, I'll give you a dish for those. Leave those there a sec. I want to show you something else first. Now then, if you saw that in an antique shop, what would you think it was?
Oh, I think it's a pretty old map of the sort of Mediterranean area.
The sort of Mediterranean area. Well, let's have a look. The geography is very good. Let's see what full marks let's see what full marks we get for the actual nature of the map. Now let's see if we can find something that we recognise. Mecca. Everybody
yes,
knows
I've heard of that.
Right. Now, have a look at that. Now you see they painted these maps with a blob of red colour on each of those little engraved towns, but if I go in close you can see that the red colour is actually printed in the form of dots. Yes. And that's very important because it shows that this map is a printed reproduction. If it was an original you'd see a red blob of paint and none of those dots would be visible. And that's the way that modern printing is done. You can see it clearer on a magazine. Now look away a moment, Carol, whilst I just find a picture.
Okay.
Now then, I'll just...
So I don't cheat?
No, you mustn't cheat. Let me just get that right. Now then, what do you suppose that is?
Look. No, then that could be a picture of the surface of the moon or some planet. Could be anything.
Well, that's the point. It could be absolutely anything, but this is how you print things in colour. You print the dots of the three primary colours. And if I zoom out, you can see that the dots actually make up a perfectly recognisable picture. That's modern printing for you by comparison.
Do you need a very high magnification to look at magazines?
No, you can almost see those with the naked eye. You could certainly see it with a magnifying glass. The objective on there is ×3. I put that there to remind you that anybody can see that, even somebody with a toy microscope at home.
All right then, what about the lunch?
Ah, that. Take the potato and cut a tiny little sliver off the end and just dab it on there so that we get some of the juice on the slide. Yes, just bang in the middle. That's enough. Right. Now I'll add that little cover slip, which makes it nicely sealed in and nice and easy to look at. And now I'll change to a slightly higher power lens, though still nothing particularly special. And there, bingo, look at that. They're grains of pure starch that the potato makes. That's why people find potatoes fattening, because starch is the potato's energy reserve. It gives it food for the wintertime.
That's incredible.
Now, let's have a look under polarized light. If you drop a bit of Polaroid under the light source and another one inside the microscope. I haven't got to buy Polaroid for this, Carol. You can use broken pair of old polarizing sunglasses if you like, cut to the fit. And if you rotate one against the other, now look at that. As the background goes dark, this beautiful cross.
That's fantastic.
Maltese cross. And that proves that the grains are made of starch. That's the typical appearance of potato starch. And if you see that appearance anywhere, it means you've got starch grains.
Oh, Brian, I never knew tatties could be so beautiful.
Tatties could... They are lovely, aren't they? It's
Yes,
a beautiful
they
sight.
are. What about these onions?
Well, the onions, we're not going to see starch grains in those, but the onions take us down to, as it were, the key to all life. The onion will give us a living cell. Just take a piece of it and use that scalpel to pull away a bit of the top surface of the onion.
Right.
That's right.
Yeah. And then what do I do?
Just strip it back towards you. Now then, you see that little tiny thin bit that's come away? Lay it down on there.
That's the bit that's quite slimy when you cut up onions.
How dare you speak of plant tissues like that? Now I'm going to take a little drop of water. Now I'm using a pipette, but any old common or garden eyedropper would do for that.
Right.
And then with a little cover slip on top, like so. If we pop potato, you will see life as it is lived in the raw. Inside each cell, there's one on the left and two on the right there, you can see the nucleus, which of course is the controlling part of the cell. Let's just see if we can...
right in the middle.
That's right. Just see if we can find a better one. Now that is a particularly good cell. It's a perfect, typical example of a living cell. It comes from an onion, but it could almost have come from you, Carol.
I don't know how to take that. The cell walls of the onion are really quite thin, aren't they?
Yes, they are. But sometimes plants produce thick cell walls, and that can give you a clue as to what they are. Taste that. See if you recognise it from the taste. It's tin
Am I
fruit.
supposed to close my eyes?
No. Tin fruit. But it's very hard to identify the taste. What does it taste like?
Well, it does taste like pear. But it's quite gritty.
It is gritty. And the reason it's gritty is because inside the pear there are what they call stone cells. And if I take a little tiny piece of that and macerate it on this slide...
You're taking my food away from me.
Only tiny bits, I have to say. It's a minute scrollop, to use a technical term. And if I just put that under there, there's cells with very, very thick cell walls. In fact, you scrunch them between your teeth when you eat the pear. Now, if we look under high power, Carol, you can see that those stone cells, they've got a thick cell wall. Some cells, you see, most of them have very thin walls. Now, do you see those lines running through from the cell inside through to the outside?
Yes.
Well, those are the pits, the channels that run through the cell wall and keep the cell inside alive whilst it's building that great thick structure.
When I used to go to school, which was many years ago...
Months and months.
Months and months, yes. We never used to analyse our canteen food, but we always used to look at things like pond life, the traditional things to see under my...
Pond life can be a disappointment, because if you just go to a pond, it may be that the organisms you want aren't there. So the best thing to do is to stand them in jam jars on your windowsill and see what grows up. Now there's a little single-celled organism called Peronema, which lives in ponds. Let's just get that in a better position. Now then.
What's it looks like a tail, but it can't be. 'Cause it's
Tail at the front. That's the flagellum, which is a whip-like structure. It sort of spins around at the far end and draws itself along through the water. That's Daphnia, water fleas.
Grief. They're busy, aren't they?
Yes, looks like a microbe disco. But even under low magnification you can see their eyes and their little feelers and their appendages inside, their little legs kicking about. And that dark curly line you can see is the gut, the intestines from the mouth to the other end. Pick one out on its own, Carol, and you can see in the back the pulsating of its heart. See that?
That's fantastic.
And those little white bits that you can see flowing up into the heart and out again are actually the blood cells.
It is quite amazing, the beautiful things that you can see under the microscope.
Yes, it is. And you know, it always bothers me that telescopes are so popular. Everybody's very keen on astronomy. But no matter how much you magnify a star, it is still only ever going to be a pinpoint of light. But a microscope takes you down inside the stuff of which we're all made. You don't need a high magnification. But at the end of it, you're walking around within the cells that make us all live.